All right, lesson 3 is the same as chapter 8, section 8.3 in your book. Combine like radicals. There's no warm-up for adding and subtracting radicals. I just want to mention a little note about the word combine. Combine is what you're referring to when you're adding and subtracting terms. Okay, so if you have 8x plus 4x and you're supposed to combine, here, let me put plus 2. If you're supposed to combine like terms, these two variable terms are like because they both have 1x to the first power, so that would be 12x plus 2. Notice that we don't change the x into something else. We don't make it x squared. Not when we're adding and subtracting. Okay, the word combine refers to adding and subtracting. So we're going to be doing that with radical terms. All right, so we don't want to change the radical when we're combining. So radicals are said to be like if they have the same index. Remember where the index is here, right? And the same radicand. All right. When adding and subtracting like, we combine and simplify the result if we need to. So, for example, you have 5 square root of 3, 4 square root of 3. They have the same index of 2, right? They have the same radicand of 3. Therefore, we are allowed to add the numerical coefficients together, and that's my new term, okay? Same indexes, same radicand. Therefore, I can add that together and get my 4. Okay? That's all there is to those. So, same. 7 plus 4 is 11. Put the rest of the answer down. Okay? 8 minus 2 minus 3. 2x. Sorry, getting my paper out to make sure I don't mess anything up. So that's going to be what? 3. So my final answer is 3 square root of x. This looks all very complicated, but right here, look, this whole thing is the same as this whole thing. So basically you want to know what 5 minus 6 is, which is a negative 1. So my final answer is negative x to the 5th. Oh, wait, whoop. That's an index. Okay, so be careful. Be careful. Writing that all down. Negative x 5th xy squared. Okay. It has to be the 5th. Yep. Okay. And this is an example of the one that won't combine. That has an index of 3. This has an index of 2, right? That's a numerical coefficient of 3, but an index of 2, even though the radicands are the same, this cannot be simplified. Okay, so you can't combine them. These you can. This is negative 3 plus 8 plus 4 minus 6 is 3 square root of 11. Okay. And then this one, all of this has to be the same. All of this has to be the same. So negative 5 plus 7 equals 2ab cubed root of z for my final answer. Okay. And then combine and simplify. Unlike radicals become like when they are simplified so they can be combined. Some unlike radicals become like when they are simplified. So in other words, they're not as nice as the ones up here. They need to be simplified. So right now, look at A. So this is not, they have the identical indexes, but they don't have identical radicands, but they're not simplified radicals. So 48 is not a perfect square. So square root of 16, square root of 3. Do not put a lower one. You have to keep going till you get to 16, okay? So if you put 6 and 8, don't forget to reduce the 8 farther, right? We need the greatest perfect square that's a factor. So this is going to turn into 4 square root of 3. This 12 is what? 4 and 3. So that's 2 square root of 3. So now here's my new problem with the same index and the same radicand. So this is going to be 6 square root of 3. Okay. So 45 is not a perfect square. 9 and 5, 3, square root of 5. This is how I do them. I like to keep everything all nicely lined up. Square root of 49, that is a perfect square, so that's a 7. 20 is not. 4 and 5. So that is plus 2 square root of 5. So this one and this one are like terms. So my final answer would be, I'm just looking at my key at the same time to make sure I'm on track here. This is going to be 5 square root of 5 minus 7. I don't have a preference for the order if your instructor does find out, but that should be good. Okay. They're not like terms. Do not add them together. They don't have the, the 7 is just by itself. It's a constant term. It doesn't have any radicals in it, so it can't be combined. Okay. Let's see. This one over here, there's nothing I can do with the first one. But 343 is not a perfect square either. So let me do that first. That's a toughie. I'd have to think of all the factor pairs in a 343. That is going to come out to this. That might be the hardest part in this part, is trying to figure out what perfect pair is a factor of 343. Turns out 49 and 7 are. So if you have to, go through your list of perfect squares and keep trying to see which 343 is divisible by. Okay, try 16, try 64, try, you know what I mean? Go through the list of perfect squares till you find the one that works, that's divisible, so it goes in by a full number. So that's going to be 7 square root. Oh, there's clearly not enough room to write this in here. And that's going to be times the negative 4. So 2 square root of 3 minus 28 square root of 7. If I did that right. Let's see what this one turns into. Square root of 25 and 3. You do these enough and you recognize them. Okay. So this is plus 15 square root of 3. So I do have two terms to combine right here. If I had any room, let me write them above. All right, so the answer to this one would be what? 17 square root of 3 minus 28 square root of 7. That should be my final answer for that one. Sorry for the tightness here. All right, back over here. Cubed root of 54. That's not a perfect cube. 3 and 27 and 2. So 3 cubed root of 2. 16 is not a perfect cube. It's a perfect square and a perfect fourth, but not a cube. So that's an 8 and a 2. So that's a 2 times 2. So this is going to be 4 cubed root of 2. And this just comes down. All right, so notice they're all three terms have the same index and the same radicand. So, whoa, that's kind of like a trick question. So 3 plus 4 minus 7 is 0. So, yeah, that's it for that one. I'm just checking. I'm just checking my notes to make sure I did it somewhere else too. So, yeah. Because the numerical coefficient comes out to a 0, 0 times the square root of 2 is 0. So that's just a big fat 0. Okay, that's tricky. All right, square root of 81 is 9. So 9x, like that, plus square root of 16 is 4. And square root of 36 is 6. Those are all perfect squares. Now they are the same radicand, same index. Add them together. 9 plus 4 plus 6 equals 19 square root of x. Okay? And then this one, square root of 75, 25, and 3, 5, square root of 3. The t's. 1 comes out, 1 stays in. So this is going to be 5t square root of 3t. All right, this one is square root of 9, square root of 3, 3 square root of 3. The t's, this is going to be t square root of t. So this is going to be plus 3t square root of 3t. Oops. That's a t. Sorry. That's a t. So right there, these are all the same. So I'm allowed to put my final answer as 8t square root of 3t. Okay?